One more problem on the topic of complex power. Already, please go through the class recordings because even it is not clear. I think the theory concepts or everything is almost clearly provided there. You will be able to see there is no struct in that I feel. So understand the concept of complex power and the equations. So now I'm just describing here only the how to do the problem. Okay. So the equations all you understand from the class recordings itself. Okay. So now this is your last problem today I'm solving is this. About complex power. Just read it. An industrial firm has two electrical loads connected in parallel. So two electrical load. This is a load, whatever. I'm just writing as a box because I'm not sure whether it is a resistance or an inductor or a capacitor or a mixed one. So just writing as a rectangle box indicate that it is an impedance. It may have inductance, capacitance, or these two are connected in parallel. Two electrical loads connected in parallel across the voltage source. So it is connected to a voltage source. How much? 5 kilovolt VRMS. So it is connected to a voltage source. How much? 5 kilovolt. That may be the peak voltage and that is VRMS range. It is okay because 5 kilovolt is given in RMS voltage. Now, another thing explained is one load is 50 kilowatt. So this is you have two load. So this is for example load 1. This will be load 2. So one load is that is 50 kilowatt heating use. So 50 kilowatt means you see from the unit itself you understand that it is power given. Average power is given because capital P. Why? Because it is not a reactive power, only pure power component is there. So first one I'll write it as P1 load. So it is equal to how much? 50 kilowatt. Now second one, and the second load has is a set of motors that together operate as a load with 0.8 lagging power factor. Understand that lagging power factor is inductive. That is J is plus J or angle is plus. Okay. So power factor is given for the load 2. Power factor for load 2 is given as 0.8. Once power factor indicates that and it is lagging, it is written inductive. That means there is a reactive element. So, with the 200 volt kilovolt ampere, volt ampere you should understand it is given as S. What is S? Apparent power. So, apparent power here is given as how much? 200 kilovolt ampere. So now what's the question here? You need to find the total current and overall power factor. So total current you want to get means because these are like loads are connected, both is having not a real power alone, you have a reactive element also. So because one something like complex power is something that it includes all the information related to the power. Average power, apparent power factor, every details are available in the complex power. So it is a complete things involved in the power, complex power, complete details of the power will be there. So just to write what is a complex power, as I told you, because complex power is also denoted by S and apparent power is also denoted by S. I told in the class that we are going to write like this as for complex power, okay? And you know the complex power, it is nothing but P plus JQ. What is P? Average power. What is Q? Reactive power. The unit of P is kilowatt. Unit of Q is VAR. So this is the complex power. So let me write the complex power for the first one. That is let be S1. Okay. And let me write the complex power for the second one. Let me that as S2. Understand that when you add S1 plus S2, you will get a total power. So once you get a total power, it is easy for you. Voltage is there, power is V into I. It is easy for you to calculate a current. So that will be the total current. And power factor, also you can get it from there. So now let us start our problem. So let me find. So it's easy for me to find the total complex power so that I can easily calculate a current. So for load one, what is the complex power? Total complex power it is S1 should be equal to real power plus JQ1. And you know that the first load doesn't have any Q element. So for the first load, Q1 is nothing is given, right? So it is 0. So what is the first one? S1 should be equal to P1. That is nothing but 50 kilowatt. This is your S1. So this is for the first load, right? Now for load 2. Let me write with another color to differentiate. Now load 2. So for load 2, you have denoted the complex power as S2. It is nothing but P2 plus JQ2. And what is given here? Power factor is given, right? And you are aware of the equation. What is P2? P2 is nothing but it is equal to apparent power S multiplied by power factor, or apparent power S into cos theta V minus theta I. Similarly, Q2, what is the equation? It is apparent power S into sine theta V minus theta I. So one is cos is the power factor. So we write like that. Another is sine theta V minus theta I. So we have to calculate now what is S2 from the given information. So now you have given yes. So this is available with you, right? Yes is there. Now what about power factor? Power factor is also available with you, 0.8. So easy for you to calculate P2. Now what about Q2? Q2 require S is available, but what about sine theta V minus theta I? You don't know, but you know power factor, right? So from the power factor, you can calculate theta V minus theta I. And when you put that, you will get a Q2. So finally, you can get the S2 like that, okay? So let me start with the P2. So what is your P2? P2 is equal to S into cos theta V minus theta I. That is nothing but S into power factor. So what is S? S is given as 200 kilo. S is given as 200 kilovolt ampere. Power factor is how much? 0.8. Power factor is 0.8. So how much are you going to get with this values? Your P2. Your P2 is equal to 160 kilowatt. So the answer is equal to 160 kilowatt. Okay, so now next step is you need to calculate Q2, right? For getting Q2, what should be that? Q2 is equal to S into sine theta V minus theta I. But you don't know what is theta V minus theta I. But you are aware on power factor. What is power factor? You have given power factor as 0.8, right? That is nothing but cos theta V minus theta I. So that is cos theta V minus theta I should be equal to 0.8. So what is theta V minus theta I in that case? Cos inverse of 0.8. So in calculator, if you find cos inverse, how much are you going to get? Is 36.8 degree. 36.8 degree. Now, since it is cos, you don't know whether it is positive or negative. So you have to decide a sign based on this. It is lagging inductive. So it should be positive. If it is leading, it would have been negative. Okay. So you got theta v minus 2. Now just substitute that value. What is your S here? S is 200 kilo multiply by sine 36.8. And how much are you going to get answer? That is equal to 119.8 kilo. What is the unit of Q? It is VAR. Okay. So now you can find P2 is there, Q2 is there. Now you can find what? Now you can get S2. So that complex power of second load. What is S2? P2 plus JQ2, right? So what is P2? P2 is 160 kilo plus J119.8 kilo. Okay. So that is your total complex power for second load. That's your complex power for second load. So if you get this, now what? You can now calculate total complex power. It is nothing but S1 and S2 you have to add. So what is the total complex power? It is nothing but S. It should be equal to S1 plus S2. So S1 is already we have calculated, right? How much was our S1? It is 50 kilowatt alone. I feel only P1 was there in your S1. So it is 50 kilowatt alone. So S1 is 50 kilowatt. So it's nothing but 50 kilo plus S2 is what? 160 kilo plus J119.8 kilo. So how much will be answer? It is first 160 plus 50 is 210, I think, right? So it is 210 kilo plus J119.8 kilo. That much watt. Now, you convert it into polar form. If you convert it into polar form, you will be getting it as 241.6 angle 29.7 degree. So associated with the angle associated with the complex power will be a power factor of total, okay? Total complex power angle associated with will be the power factor. So understand that this is supposed to be theta V minus theta I. Because this will be of the form S. S angle theta V minus theta I. So understand that this is supposed to be S. S is the apparent power. Notice complex power, apparent power. You can see the sign of S, okay? So you got the total apparent power, you got the total power factor because angle is there, cos of that angle will be your power factor. So now let's see the question what is asked. Question asked is overall power factor and total current. Overall power factor is easy to get. Total current is also easy because total current is total current. We know already that the complex power S is equal to a power it is, right? It is VRMS multiplied by IRMS. And if it is like this, what is IRMS? What is the current? This S divided by VRMS. So already you are aware what is S, because IRMS should be equal to S divided by S is, it is only the magnitude part, okay? Because S is not complex, sorry, it is rather S. But apparent power S equation it is, okay? I'm so sorry to say that. Apparent power S is equal to Vm Im by 2 or Vm by root 2 and I into Im by root 2. So this is apparent power S is equal to Vr. You know apparent power S is equal to Vm Im by 2, right? Or it is like Vm by root 2 into Im by root 2. It is nothing but what? Vrms into IRMS. So, what is IRMS? IRMS is S by VRMS. S by VRMS. So, how much is your S? Already you know, S you already got it as 241.6. So, 241.6 is your S. It is kilo, okay? This is actually kilo. Okay. So, it is that much kilo is your S. And divided by VRMS. How much is the RMS value given here? In the question, it is given as 5 kilovolt VRMS. In the question itself, it is given 5 kilowatt VRMS. So, it is 5 kilo. 5 kilovolt VRMS. So, your answer will be 48.32 ampere. So this is your IRMS. Okay. Now second part is overall power factor. Already you got to theta V minus theta I. So overall power factor is easy for you to get because overall complex power you got. The corresponding angle is theta V minus theta. I already told here 29.7. So you know that theta V minus theta I overall is 29.7. So what is power factor? Power factor is cos theta V minus theta I. So it is cos 29.7. It is equal to 0.86. So this is what is your answer of the complex power question. The concept is still not clear. Please understand from the theory part how the equations appears. Okay.